Well, today we're going to talk about section 5.1, and this is video A. And the question is how to measure distance traveled. And what I'm going to start out with is some graph, and let's have miles per hour here, and let's call this F prime of x, because this is a rate. We'll have miles per hour, and so x will be in hours. And where this begins is really a unit analysis type question. If I was going to look at any area here, the vertical would have units, miles per hour. The horizontal has units, hours. And so if I multiply these together to get that area, that'll be miles per hour times hours, and murder occurs and I just get miles. And so the takeaway here is if I have a derivative and I multiply that derivative by some x value, or in other words, look at the area underneath it, we can get how many miles has passed. The area under a velocity curve is the total distance traveled. Sweet. So now that we have that, the question is, what's the best way to estimate area under a curve? And if I was going to draw something like this, maybe some of us would say that you would want to maybe use like a little half circle there, and then a rectangle, and then maybe you would use like a trapezoid, and maybe here we could use a rectangle. And these are all great ideas. But in order to make this thing uniform, we're going to establish a couple of ground rules to estimate area. And here are the ground rules. Rule number 1, we only want to use rectangles. Now, when you take Calc 2 and other calculus courses, you'll use different shapes. But right now, we're only going to use rectangles. And rule number 2 is we want these rectangles to all have the exact same width. Okay, so I'm going to give us a problem here, and I'll give us some function f prime of x, and let's start here at 1, and I'm going to end at 3. Not a very good 3. That's 1. We'll change at 5. And so if I'm going to go from 1 to 5, if I wanted to do, say, 2 rectangles, the width would be 5 minus 1 divided by 2, because there's going to be 2 rectangles that go down, and so the rectangles are each going to be 2 wide. So I'll have a rectangle from 1 to 3, and I'll have a rectangle from 3 to 5. So that's fine concerning our widths of our rectangles. The question is now, what should the heights of our rectangles be? And I have 2 options available to me. I can use a right-hand height. And in doing the right-hand height, I'm going to use the right-hand side of the rectangle. So I will use, in this case, f prime of 3 as my height. And on the other side, I'll use f prime of 5. And so my area using the right-hand heights, and we're going to refer to this as a right hand sum, is f prime of 3 times 2, which is the width of our rectangle, and that gave us this area, plus f prime of 5 times 2, and that gave us this area right there. Okay, and that's an estimate for the area underneath f prime between 1 and 5. That's our right-hand height or our right-hand sum. The other way I could attack this, and I'm just going to redraw very quickly what we had here. Here was 1, here was 3, and 5, and this is still f prime, is I could use my left-hand height. And that means that given the rectangle that's going to go from 1 to 3, I'm going to use the height at 1 as the height of my rectangle. Multiply that by the width. And then finally, I'll use the height at 3. For the height of my rectangle multiplied by the width. And this we can refer to as our left-hand sum. I'll just usually use LHS or RHS. Now, in either cases of these sums, you should see something that I should be able to do. Because I said that the rectangles will all have the same width, I should be able to factor this 2 out. And I'll have f prime of 3 plus f prime of 5. And these are just the outputs of this function, right? I'm just saying that when I have a derivative, it makes sense to get the area underneath because the units will just be miles. And similarly, I can factor out the 2 and we'll have f prime of 1 plus f prime of 3. Now, all we're doing here is I am figuring out a way to estimate the area underneath a rectangle or underneath a curve. And I made 2 rectangles here. Let's make one last idea. And if I had the same f prime here, and I wanted to go from 1 to 5, you know, I could make more than 2 rectangles if I wanted to. I could make as many as 10 rectangles. And if I was going to do 10 rectangles, how wide would each one be? Well, the total width here is 4. Divide that by 10, so it would be 5 minus 1 over 10, which is going to be 0.4 is our width. And so I would go from 1 to 1.4 and then 1.8 and then continuing in that fashion until I got to 4.6 and then to 5. And so all of these rectangles are 0.4 wide. And then if I wanted to use the left-hand sum here, just for fun, doesn't really matter which one I'm using as of yet, I could say that I would multiply the height at 1, f prime of 1 times 0.4, plus the height at 1.4 times 0.4, and continue until exhausted from my toils, and I would wind up with 0.4 times the height at 4.6, that final rectangle. Once again, as a math student, I am totally interested in factoring. And so I would factor out the 0.4 from everything, and I would be left with f prime of 1 plus f prime of 1.4 plus f prime of 1.8 all the way down the road until I got to f prime of 4.6.